Okay, for my chapter 3 problem, we're going to be looking at the human body and its way of regulating internal body temperature and quantifying the heat loss from the body and temperature at a specified location. So in a problem like this, we have to have a whole set of knowns, and it's the same overall heat transfer equation, but it's the way the resistance is calculated is what will be different here. So in the figure below gives a whole set of knowns that we need to know about the human body that was given in chapter 3.7 for the bioheat transfer in our textbook. These values were. And then we just need to calculate our resistance total to go ahead and solve, but this is a kind of a twist on the heat transfer equations we've been doing in the class. So in this problem, we'll go over like learning outcome 2. So the modes of heat transfer. In this, there is conduction, convection, and radiation. So the heat transfer by conduction is in parallel, and the skin and fat is in parallel with heat transfer in the form of convection and radiation. So these are all different ways of solving for our resistance total. And this is a physical situation of the human body that happens every day. So it's a good twist. For the third learning outcome, we're treating it as a steady state, one-dimensional heat transfer for terms of like simplicity at this point, and interpreting and gathering necessary data on these fluids. So there's a whole slew of parameters that we must know, like blood density, specific heat, the thickness of muscle, skin, fat, the emissivity, the density, and others all need to be gathered and to evaluate this problem. And then for learning outcome 5, the fundamental equations of heat and mass transfer for a conductive system, identifying boundary conditions and solving analytically and numerically. So for these, we are solving for the temperature in a 1D system based on an equation that we derive for our heat transfer. So that is how learning outcome 5 will be isolated in this problem.